Hi everyone, the SAT and NTHP IBA-Karachi aspirants. I have selected some questions from SAT, College, Panda, entrance test. Without wasting time, just start our work. Mostly these all questions are based upon how to handle exponent, having another exponent, what do you mean by square root, cube root, fourth root, in general, nth root, how to merge them, how to solve them, how to get them along. Today's frame is based on that. Question number one, without us wasting time, our expression is given to us cube root of x square overall raised n cube. Let me check whether it is green is visible or not. Green is not as visible as it must be. Or let me write with blue. Cube root of x square overall raised n. Overall raised n. Is it visible? Okay, is it visible? Yes, it is visible. Where n is a constant equivalent to x8 means we have cube root of x square overall raised n is equivalent x raised 8 x raised 8. What is the value of n? What is the value of n? Twist it again. First is we have given expression indirectly equivalent to x power 8 means it is equal to x raised 8. First of all, handle cube root. Handle cube root. Cube root of x square can be written as x x raised 2 over 3, 2 over 3, cube root. This 3 comes in the denominator of this 2, in denominator of this 2. Overall raised n is equal to 8. Power, having another power, multiply the powers, and it is multiplied with n multiply with 2 only. 2 over 2 times n over 3 is equal to x raised 8. We are familiar, as bases are equal, therefore powers are equal. Compare the powers, equate the powers, solve for n. 2n is equal to 8 times 3 is equal to 24. 8 times 3, 24. Then n is equal to 24 divided by 2. N is equal to 12 in that case. So value of n is 12 in that case. Value of n is 12 in that case. We have given cube root of x square raised n is equivalent to x raised 8. Is equivalent to x raised 8. We are interested in n. Get rid of this cube root. It can be written as 2 over 3 times n. Power, having another power, multiply the powers in that situation. 2 times n over 3 is equal to x raised 8. Bases are equal, therefore powers are equal. 2 times n divided by 3 is equal to 8. Shift 3 here. 8 3 the 24. Shift 2 from multiplication to division, n is equal to 12. Let me verify for you this question as well. Put the value of n, that is n is equal to 12. Plug in here and see what happens. Cube root of x square raised n means 12. It must be equal to x raised 8. It can be written as x square x raised 2 over 3. This 3 comes in the denominator of 2. Overall raised 12. 3 for the 12. Power, having another power, multiply the power. X square times 4, it will become x8 is equal to x8 as required. So value of n in that case is n is equal to 12 by applying simple tiny exponent rule. N is equal to 12 is our answer. Question number 2. Which expression is equivalent to 2 raised negative 2k times 3 raised k? And we have some 4 options. We have an expression 2 raised negative 2 times k times 3 raised k. We have to sort this one out in this. If we inspect the all options, they are all powers of k. They are all exponents of k. They are all exponents of k. So we have to get rid of this 2 raised negative 2, and we have to merge this. Power of 2 is alone and power of 3 is also k. Their power is k. We have to figure it out, write as a single term raised to k. single term raised to k, 2 raised negative 2 times k. We can write this 2 raised negative 2k. 2 raised negative 2k can be written as 2 raised negative 2 times k is equal to 3 raised k. Now just take this portion, only this portion. Turn the negative exponent to positive. It can be written as 1 over 2 square raised k times 3 raised k. 2 square means 4. Square of 2 is 4. 1 raised k times 3 raised k. Here they both have power k. They both have power k and they are in multiplication. It can be written as 1 upon 4 times 3 overall raised. They have same power. They are in multiplication. I can write 1 upon 4 times 3 as this one. Or this one can be written as 1 3 the 3. 3 over 4 raised k. 3 over 4 raised k. 3 over 4 raised k. In that case, C is our right option. C is our right option. We have given 2 raised negative 2k times 3 raised k. If we inspect the options, option is the driving tool, is this your steering. Move yourself towards option. Look at this. They give us ample hint that overall power must be raised to k. We have merged all these things into a single term having power k. Single term having power k. I have written 2 raised negative 2 times k. Turn negative exponent to positive. It can be written as 1 upon 2 square raised k times 3k. 1 upon 2 square means 1 upon 4 raised k 3 times raised k. Both have same power. They are multiplication. I have written 1 upon 4 times 3 raised k. 1 3 3 3 or 4 raised k is our final answer. Question number next 13. Which expression is equivalent to a raised to over 9 times a raised to over 3 raised to over 3? Let me write the question. A raised to over n 2 or 9 times a raised to over 3 raised to over 3 raised to over 3. Power having another power, multiply the powers. Write this one same, a raised to over 9 times 2 to the 4, 3 3 to the 9. Now we have something like 2 over 9 times a raised 4 over 9. Bases are same, they are in multiplication. Add the powers. Write a 1 times. We have 2 over 9 plus 4 over 9. As denominator is homogeneous, as denominator is homogeneous, 2 over 9, 4 over 9. Denominator is homogeneous, right, and 9 1 times, 2 plus 4. No transition in numerators. 6 over 9. Apply table of 3. 3 is the common factor. They can be written as 6 over 9 can be written as relatively prime 2 over 3. So A 9 is our LCM in that case, 2 plus 4. Denominators are homogeneous, same, right, and 9 1 times, no transition in numerators. We have a raised 6 over 9. Applying table of 3, it will become a raised 2 over 3. A raised 2 over 3. Our final answer in that case is a raised 2 over 3. A raised 2 over 3. We have to find its equivalent. This cube can be written as this 3. It can be written as cube root of a square. A raised 2 over 3 can be written as cube root of a square, cube root of a square, cube root of a square. It tallies our situation. It tallies our situation. Moving towards question number next. Question number 14. The next question number 14. Which expression is equivalent to 4 over 9 times 2 over 3 raised a? 4 over 9 times 2 over 3 raised a. Now we have no idea what is the value of a. Is any real number? Is any real number? Nothing has been mentioned about a. Nothing has been mentioned about a. So we cannot touch this term. However, 4 over 9 can be converted to 2 over 3. 4 over 9 can be converted to 2 over 3 as 4 can be written as 2 square 9 can be written as 3 square times 2 over 3 raised a. They have same exponent. They have same exponent. It can be written as 2 over 3 raised to times 2 over 3 raised a. Now they are bases are same. They are in multiplication at the powers. Write base 1 times 2 over 3. Add the exponents 2 plus a. 2 plus a. It's our answer in that case. It's our answer in that case. We have the situation 4 over 9. 4 over 9 times 2 over 3 raised a. 2 over 3 raised a. There is nothing has been given about a. Nothing has been given about mentioned about a. So we have touched that situation. 4 upon 9 can be converted to the power of 2 over 3. I have written 4 2 square 9 3 square. They have same power. I have written 2 over 3 raised square. Raised square. Tiny exponent rule. After that, bases are same. They are multiplication. I have written base 1 times and I have merged the powers. Added the powers 2 plus c. It's our answer in that case. Moving towards question number next. Yes. Moving towards question number next 15. 15. In previous question, our right option is this. Question number 15. We have fourth root of x cube. Fourth root of x cube. Fourth root of x cube times 12th root of x5. 12th root of x5. Now, fourth root of x cube times 12th root of x power 5. The given expression is equivalent to this one. We have to convert this into such type of expression. Mth root of x raised n. Mth root of x raised n. If this can be merged, compactly written in that form, then what is the value of m and n? What is the value of m and n? Where we have been restricted, we have some constants to satisfy. M and n are positive constants, each less than 10, both are less than 10, and x is greater than. If x is 1, then everything is meaningless and they are all equal to 1. What is the value of m over n? We are interested in the value of m over n. Let's see and find out. We have fourth root of x cube. Fourth root of x cube. This one can be written as x raised 3 over 4. Fourth root of x cube can be written as x raised 3 over 4. 12th root of x power 5 can be written as x raised 5 over 12. Here, bases are same. Bases are same. They are in multiplication. Bases are same. They are in multiplication. Add the powers. X raised 3 over 4 plus 5 over 12. Taking LCM, x raised 12 is the LCM. Here comes 3 3 is 9 plus 5. We have x raised 14 over 12. Make them relatively prime. Apply table of 2. X raised 7 over 6. 7 over 6. This situation can be written as mth root of n. It can be written as n over m. N over m. N over m. So, in that case, n over m is bases are equal, therefore powers are equal. Bases are equal, therefore powers are equal. So, n upon m is equal to 7 over 6. 7 over 6. But we are asked to find m over n. M divided by n. Make them reciprocal. Make both of them reciprocal. M over n is equal to 6 over 7. 6 over 7. We have arrived at the situation. N over m is equal to 7 over 6. From this, we can infer or deduce the value of m and n. But we are asked to find the ratio of m ratio n. M ratio n. I have tilted both the sides. I have inverted both the sides. I have taken multiplicative inverse of both sides. It will become m over n and it will become 6 over 7. So value of m over n is 6 over 7 in that case. Moving towards question number next. Moving towards question number 16, the last one. But a good question, good question. Two numbers p and q are each greater than 0. Each greater than 0 means p and q both are non-zero. P and q are both non-zero. P does not equal to 0 as well as Q does not equal to 0. P and Q are two non-zero numbers, and the square of P is equal to the cube root of Q. Square of P square is equal to cube root of Q. We have given this situation. The square of P is equal to the cube root of Q. Square of P is equal to cube root of Q. Cube root of Q. We have given this situation. Number one, it is the given part, if part. Then for what value of x? We are interested in the value of x. For what value of x? P raised 1 minus x is equal to the square root of q. Square root of q. For what value of x? P raised 1 minus x is equal to square root of q. Square root of q. We are interested in the value of x. We are interested in the value of x. Again, what we have given, P and Q are two numbers, two non-zero numbers, are each greater than 0. They are greater than 0. Greater than 0 means both are positive. P is greater than 0 as well as Q is greater than 0. Both are positive. And number one, square of P is equal to cube root of Q. Square of P is equal to cube root of Q. Furthermore, if P raised 1 minus x, is equal to square root of Q, then what should be the value of Q, value of x? What should be the value of x to be inserted here to get both sides equal? That's our key. That is our if part to be utilized to get here. It is our key. It is given to us. It's up to you. Shift each and everything. Solve for P or solve for Q. If you solve for Q, then you have no more fraction in the power. Solve for Q, in that case, we have P square is equal to Q raised 1 over 3. To get rid of 1 over 3 cube root, cubing both sides, we have P square whole cube as well as Q raised 1 over 3 overall cube. 3 has been neutralized, cancelled. We have P raised 6 is equal to Q. So, instead of Q, we can plug in P raised 6. How I have handled the situation? Square of P is equal to cube root of Q. Here, if I get rid of this 2, I will get P is equal to Q raised 1 over 6. Fraction in the power, difficult to negotiate. To make the life simple, to keep the life simple, I have solved for Q. To get rid of this 3, I have taken cube both sides, and I have Q is equal to P square times 3, 2, 3 is 6, Q is equal to P raised 6. Just plug in here. I have P raised 1 minus x. Instead of Q, I can write P6. Square root means 1 over 2 power. So I have something like this. P raised 1 minus x. P6 raised 1 over 2. P raised 6 times 1 over 2. Applying table of 3. I have P raised 1 minus x is equal to P raised 3. Here bases are equal, therefore powers are equal. 1 minus x is equal to 3. Solve for x. Shift x here, 3 here. I have 1 minus 3 is equal to x. So x is equal to minus 2. One can verify by putting minus 2 here, and we arrive at the same situation. Let's verify the condition. Let's verify the given condition. Our x is equal to minus 2. Let's see and find out. P raised 1 minus x means minus 2. And we have solved for Q. Our Q is equal to P raised 6. Minus plus it's our P cube. And that is square root of P raised 6. P raised 6 overall raised 1 over 2. Applying table of 2. I have p cube is equal to p cube, the tiny verification, I hope you have enjoyed the exponent journey along with me. I try my best to select some good questions, They appeal to your brain. They at least give you a jolt of 10 volts, 20, and sometimes it's complete 220. It's all by itself next.